What we're going to look at in this video is algebraic long division. Now this is a vital skill that you have to be able to do higher in order to actively and accurately divide a polynomial which has a cubic degree or higher by a linear factor. So for example, 3x cubed plus 4x squared minus 3x plus 2, dividing that by x plus 2. Algebraic long division allows us to do that. Now, if you think back to when you did previous level mathematics, and you're looking at long division involving numbers, it was actually fairly easy once you got into the habit of it, because it was a repetitive set of steps. You did the same steps over and over again until you got to a point where you were no longer able to do the steps again. Algebraic long division is the exact same. It's a repetitive set of steps, it's got a repetitive nature to it, and we repeat these over and over until we can no longer do it. Best way that this could be illustrated is with an example. So let's go to that example I mentioned at the start. So let's imagine I'm taking 3x cubed plus 4x squared minus 3x plus 2, and I'm dividing it by x plus 2. Now, laying it out, you start the exact same. We lay out our step sum, and underneath we put what is being divided, so our 3x cubed plus 4x squared minus 3x plus 2, and then on the outside we put what is dividing, so our divisor, our x plus 2. Now, when we're doing algebraic long division, the key part to focus on, to begin with, is the x, so the first part of the divisor. And what we do is we say, right, how many times can x go into this first term? So how many times can 3x cubed be divided by x? What do we get left over? Well, if we do 3x cubed divided by x, we get 3x squared. So that's what we write on above our division sum. Now, the next thing we have to do is take this and multiply the entirety of our x plus 2 by it. So we'd do 3x squared times the x plus 2. And we'd write our answer underneath. So we'd say, right, 3x squared times x, that gives me 3x cubed. 3x squared times 2, that gives me plus 6x squared. And what we do is we treat this just like we would a normal long division. So just like we would a numerical one, we subtract. The key thing you'll notice here is that this first term, so the highest power, disappears. So 3x cubed take away 3x cubed gives me nothing. So we're whittling down the powers as we work this through. And we just work our way along. So we do 4x squared take away 6x squared, so we get minus 2x squared. We then do negative 3x take away, well, there's nothing underneath these bits, so we just imagine we're taking away nothing. So we end up with 3x, and then plus a 2. Now, the key question you have to ask yourself at this point is quite simple. Is the highest power here bigger or equal to the highest power there? If the answer to that is yes, we have to repeat the steps. And we keep repeating until we say to ourselves, is the highest power here less than the highest power here? If it's exclusively less than, we're done. We can no longer do a division. We've finished the calculation. So, what we now do is we look here again, we take the x and we say, right, how many times can x go into negative 2x squared? Well, if I divide negative 2x squared by x, I'm left with minus 2x. And again, I do the same set of steps again, take this and multiply the x plus 2. So I end up getting negative 2x squared, then got negative 2x times 2, minus 4x. And then again, we take it away. It's just a repetitive set of steps. The same thing happened here, same thing happened here. Funnily enough, the same thing will happen on the next step if we're able to do the calculation again. So negative 2x squared take away negative 2x squared gives me 0. It cancels. Perfect. Negative 3x take away negative 4x gives me x. And then 2 take away nothing just gives me a plus 2. Great. What I now do is I then do the exact same thing. So there's my x, and there's my x. The highest power here, remember, is equal to the highest power there, so we can go one more time. X into x gives me 1. So we get 3x squared plus 2x plus 1. And then I take the 1 and multiply it by the x plus 2. So here I end up with x plus 2. We then do our same step again, so we subtract them from each other. X take away x is 0. 2 take away 2, well, that's 0. So there's absolutely nothing left. Great. What that means is we've finished our calculation. So what that means we're able to say is fine. So 3x cubed plus 4x squared minus 3x plus 2 divided by x plus 2 equals 3x squared minus 2x plus 1. Here's the answer for the calculation. Now, one thing you will notice is that there's a 0 here. There's nothing remaining at the very end once we've completed the calculation. This has an implication. What this means is that x plus 2 is a factor of our original equation. So x plus 2 is a factor of 3x cubed plus 4x squared minus 3x plus 2. But if there's something here, it isn't a factor. It's not a factor of the original equation, so we'll have a remainder, and that has to be included at the end of the calculation. So let's have a look at an example with that. Let's imagine what we're going to do is we're going to do 4x cubed minus x squared plus 2 divided by x minus 1. Now again, we set up our calculation the same way. We set up our steps up, and we start to put the equation under it. So 4x cubed minus x squared. Now one thing you'll notice is there's no x value here. There's no x to the power of 1 value. Leave a gap. If there's any missing terms as you go down the numerical powers, leave spaces because they'll come in handy a little bit later. And we then have a plus 2. We put our divisor on the outside, so we put the x minus 1 on the outside, and we ask ourselves the same set of questions. If I do 4x cubed divided by x, what do I get? Well, 4x cubed divided by x gives me 4x squared. I then do the same step again that I did before, where I take the 4x squared and I multiply the whole of this. So I end up getting 4x cubed, take away 4x squared. And again, the same step comes into play now. I subtract it. 4x cubed take away 4x cubed is nothing. Negative x squared take away negative 4x squared. Well, that gives me 3x squared. Got nothing here to take away. And then I've got 2 take away nothing. Plus 2. Again, you'll notice I've left a gap here for where the x would come into play. Again, this will come in handy in a minute. Look at the highest power here. It's bigger than or equal to the highest power there. We go again. 3x squared divided by x. Well, that would give me plus 3x there. We then take 3x and multiply the whole part here by it. So 3x times x minus 1 gives you 3x squared, take away 3x. And again, we subtract. So 3x squared take away 3x squared is nothing. Again, this is where the gap comes into play because I've got nothing here, but it's take away negative 3x. So it's essentially 0x take away negative 3x, so 0x plus 3x. We get 3x there, and then I've got 2 take away nothing, so I've got plus 2. At this stage, we do the same thing. Highest power here, well, it's equal to the highest power here, so we can go one more time, and we do the same set of things. X into the 3x, that just simply gives me a plus 3. We then take the plus 3 and multiply the x minus 1 by it, and we get 3x minus 3. And again, we then subtract it. So we do 3x, take away 3x, gives me nothing. 2 take away negative 3, gives me 5. So now, we're at the end of our calculation. We've done all the division we can. We now just have to tell them what we've got. So what we'd say is fine. So that 8, therefore, 4x cubed, take away x squared, plus 2, divided by x minus 1, equals, and there's our answer there, 4x squared, plus 3x, plus 3, remainder 5. This 5 here is now a remainder. And this has the implication that x minus 1 is not a factor of 4x cubed minus x squared plus 2. And that's what it means if we get any remainder here. If we're ever asked to prove if something's a factor and we do algebraic long division, we're looking for this to be 0. If it isn't equal to 0, it's not a factor. So, as I've said, algebraic long division is very, very similar to long division involving numbers. It's the same repetitive set of steps we do. Take the first number here and divide it by the first number here. Put your answer there, multiply the whole thing through, write it underneath, subtract it. Then you compare your powers. If the highest power here is bigger than or equal to the highest power here, we have to go again. And we keep going until we get to a point where that is no longer true. Algebraic long division, fairly straightforward.